Hello student, the question says a DC ammeter and a hot wire ammeter are connected to a circuit in series. When a direct current is passed through the circuit, the DC ammeter shows 6 ampere. When AC current flows through circuit, the AC ammeter shows 8 amperes. What is the average readings in DC ammeter and the AC ammeter if DC and AC current flows simultaneously through the circuit? So let us look at this scenario. We have a DC ammeter and an AC ammeter. First, you have to know what does a DC ammeter reads. So a DC ammeter reads average value of current. Then what does an AC ammeter reads? AC ammeter reads RMS values. Reads RMS values. So this is how it works. A DC ammeter would read the average value of the current and an AC ammeter reads the RMS values. Initially, it is given when a direct current is passed through the circuit, the DC ammeter shows 6 amperes. So we have sent a direct current of 6 amperes into this. So when somehow we have adjusted all these things and we sent a direct current of 6 amperes. This is a DC current. That means the average value of the current that we are sending is, so IDC average value. This is how we indicate an average value. It would be 6 amperes. If you notice it in the question, he has not mentioned when AC current flows through the circuit. He did not mention what would be the reading in the other one. Like what would be the reading in AC ammeter when a direct current is passed through it. Even when the direct current is passed through it, there would still be some reading in the AC ammeter also, but it is irrelevant for this question. Now let us read the next one. When an AC current flows through the circuit, when we say AC current, generally we assume AC current as sinusoidal. AC current as I equals to I naught sine omega t. So if nothing is mentioned, we will take a very simple case of AC current, which is sinusoidal, I equals to I naught sine omega t. So when that is going, what would be the reading in DC and what would be the reading in AC? So the reading in DC, the average value of a sine curve is 0. Why? Because if you look at the graph of a sine curve, the upper area would exactly counterbalance this lower area. So we'll get IDC as 0. And so when an AC current is flowing through this, the DC ammeter will not show any readings. Now the AC ammeter would show a reading of IRMS. So IRMS of I naught sine omega t is I naught by root 2. And this is what our AC ammeter shows. He has given when an AC current flows through the circuit, the AC ammeter shows 8 amperes. It simply means that IRMS equals to 8 amperes. We can write the equation of current also, then I equals to 8 root 2 sine omega 2. I will call this I2. I will call this DC current that initially we sent as I1. Now he's saying both the currents are sent simultaneously. So now the question is, if I equals to I1 plus I2, then we have to tell what would be the reading in DC ammeter and what would be the reading in the AC ammeter. So I equals to I1. We know the value of I1 as 6 amperes plus the value of I2, just we have obtained 8 root 2 sine omega. Now reading in DC is simply the average value of phi. The average value of phi is average value of 6 plus average value of 8 root 2 sine omega t. For a sinusoidal function, we know the average value would be 0 and average value of 6 is just 6 only. So in the third case where we sent both of them simultaneously, the current reading in the DC ammeter would be 6. Now, at the same time, we know I equals to 6 plus 8 root 2 sine omega t. We have to find the RMS value. So reading in AC AC would be simply IRMS. IRMS, if you have both combination of AC and DC, you have to do IRMS of DC square plus IRMS of AC square. How this equation derived right now, this video would become very lengthy to get into this. Just remember that if you have both DC and AC as a combination, so the IRMS would become IRMS of DC square plus IRMS of AC square. For the first one, since it's a constant number, the IRMS also would be the same thing. So it would be 6 only. So it would be 6 square. For the second one, 8 root 2 sine omega t, the IRMS value is 8, 8 square. So root of 6 square plus 8 square would be 36 plus 64. So it would become root 100, which would be 10. So we got the reading in DC as 6 amperes, the reading in AC as 10 amperes. So 6 amperes and 10 amperes is present in option 1. So the correct answer for this would be option 1. Again, I will repeat what this question is all about. We have a DC and an AC ammeter. We have sent a 6 ampere current and the reading in the DC ammeter is 6 amperes. So we can directly tell the average current that we are sending initially, that is the DC component of the current, is 6 amperes. And after that, we have sent a sinusoidal current through this. A sinusoidal current whose equation looks this way, and our AC ammeter is reading 8 amperes. That means indirectly is telling you what is the IRMS value. The IRMS value he is giving it as 8 amperes. Using that, I found I2. Because two currents are mentioned. One is DC current, another one is AC current. Now both the currents, DC current and AC current, are sent simultaneously through this. So we'll just write the final equation of this. Once we write the final equation of this, we use reading in DC, reading in AC, and to solve this. So to explain you, it took so much time, or else you could solve it instantly after reading the question. Hope you understood how I have solved.